Hello students, today we are going to see the environment of a UNIX process. Here we are going to see introduction, main function, process termination, command line arguments, environment list, memory layout of a C program, some of the shared libraries, memory allocation, environment variables, set jump and the long jump functions, set R limit and the get R limit functions, Unix kernel support for process. First we will start with the main function. Okay, a C program, it will start the execution. Main function is the entry point for the execution of the program. Okay, so the prototype for the main function is here it is going to return the int value. Take a two parameters or the arguments, that is argc and the argv here, where argc is the number of command line arguments, how many command line arguments you have sent. That count will be present in the argument count, that is argc, and the pointer to those arguments will be present in the argv here. The next is process terminations. There are 8 ways for process to terminate. Okay, so there are two forms of process termination. The first one is the normal process termination and the abnormal termination. With the normal termination, it will be done in 5 different ways. With the abnormal, it will be done in the 3 different ways. The first one will be the return from the main. Just if you are going to call the return from the main, then the process will be terminated normally. Then second is calling the exit there. If you are going to call the exit functions, your process will be terminated normally. Then third will be calling underscore exit or underscore capital exit is there. Okay, here also it is going to be written from the main functions. Okay, then what is the difference between exit and underscore exit here? Whenever you are going to call the exit function, some cleanup process will be done, whereas whenever you are going to call the underscore exit, no any cleanup functions will be called. Immediately they are going to return to the kernel. Then the fourth form is return of the last thread from its start routine there, then calling the pthread exit from the last thread. Abnormal terminations, a recipient of a signal, any signal if you are going to get from the external devices like abort or something, that will be done. Response of the last thread to a cancellation request and calling the abort function. So these are the three different ways for the abnormal termination of the next is exit functions. Three functions terminate a program normally, that is underscore exit and the underscore capital E exit, which is going to return the kernel immediately, whereas exit function which will perform some certain cleanup processing and then they are going to return to the kernel. Cleanup means if they are going to access any local variables or anything, those things will be written and that memory deallocation will be done. That operation will be performed by the exit functions there. Okay, this is the syntax for using the exit and the underscore exit. Int status will be there, and this one will be for the underscore exit int status. So to make use of the underscore exit, you have to include the unistandard header file, whereas the exit and the underscore capital exit e exit, then there you have to use the standard libraries. Here, null string, path, shell, user, login, these all are the environment strings, okay, which will be ended with the null character. Those will be sent as a value to the each program. The address of the array of pointer is contained in the global variable environment exter, that is character star star environment. Generally, any environmental variable is of the form name is equal to value form. Okay, so that environment information will be present in the environment variable. Next is memory layout of a C program. A C program has been composed of the following pieces. The first one is the text segment, the machine instructions that the CPU is going to execute. Okay, whatever the program you are going to write, that is called as the text segment. Then next, initialized data segment, usually called as the simply the data segment, containing the variables that are specially initialized in the program. For example, if you are going to use any variable and if it has been initialized to some value, that will become under your data segment. Then uninitialized data segments. Data in this segment is initialized by the kernel to a arithmetic zero or null pointers before the program starts its execution. So if you are going to declare any array or variable which you are not going to initialize any value, those will become under your uninitialized data segment there. Then next is the stack where automatic variables are stored there. Okay, so in the stack the automatic variables will be stored. Those will come under the your stack segment. Okay, then heap is there. Heap where dynamic memory allocations will be take place there. So the dynamic memory allocation variables will be stored in the heap. Historically, the heap has been located between the uninitialized data segment and the stack segment there. Next is memory allocation. That ISO C specifies the three functions for memory allocation: malloc, alloc, and the realloc is there. Malloc, which is going to allocate a specified number of bytes of a memory. The initial value of the memory is indeterminate. Okay. Calloc, which is going to allocate a space for a specified number of objects of the specified size. The space is initially initialized to 0 there. Calloc. Realloc, which is going to increase or decrease the size of previously allocated area. We'll see the syntax. Malloc, it is all three functions are going to return the void pointers there. That is the memory allocated memory address. Size, then the size, number of object, and the size here you have to pass for the calloc, and void point reallocation, that is the previous pointer, then the new size we are going to pass. All three are going to return the non-null pointer if it is okay, that is the allocated memory location address. Here they are going to return the null as an array there. Then void free is there, which will be used to release the memory which has been allocated by the malloc, calloc, and the realloc. Next, environment variables. The environment strings are usually of the form name is equal to value. The shell from, for example, use the numerous environment variables. Some such as home and the user are set automatically at a login time and others for us to set. The functions that we can use to set and fetch the value from the variables are set environment and the put environment and the get environment. Okay, set, see, first we will see the get the environment information. Constant character means that you have to pass the environment variable name as a parameter, so pointed to the value which has been associated with the null if it is not found. Put is there, just you are going to put the value to that environment. Set environment, constant name, constant value, and if you want to rewrite it, that will be there. Then unset the environment variable. If you want to unset the environment variable, even that will be. Next is set the jump and the long jump functions are there. Here we cannot go to a label which has been present in the another function. Normally this thing is present in the C and C++. Okay, we cannot directly pass the control from main function to the sub functions. Okay, just we have to make a call. If you are going to use any go to statements or anything, directly we cannot move. But instead, we must use the set jump and the long jump functions to perform this type of branching in case of our Unix operating system. These two functions are useful for handling the error conditions that are going to occur deeply nested function calls there. Hash include setJump.h, setJump, jump buffer environment. Return 0 if called directly, non-zero if returning from a call to a non-jump, long jump. Long jump is there, here buffer environment and the int value will be there. The environment variable, the first argument records the necessary information needed to continue the execution. The environment is of the jump buffer defined in the setjump.h file where it contains the task. Example for the setjump and the long jump. Just we will see here I have declared one buffer. Okay, so I have created one line with the maximum line. Then set jump of buffer is not equal to 0 means what it is? It is a error. While if you are going to get a line, maximum line standard is not equal to null means do the line and exit. Okay, here set jump, you are going to call the set jump here. See, long jump, jump buffer comma 0. So from here to here you are going to jump away, which is not possible normally in the C. But here if you are able to jump from one function to the another. Next is get rlimit and the set rlimit functions. Every process has a set of resources limit, some of which can be queried and changed by the get rlimit and the set rlimit. That is get resource limit and set resource limit functions there. You see the syntax here: get rlimit int resource structure rlimit, the pointer to the r limit is there. Okay, the pointer to the r limit is there. Then the set r limit int resource constant struct r limit and the pointer to that r limit is there. So we will see what do you mean by resource here. Resource argument takes one of the following value. See here, r limit core means the maximum size in bytes of a core file. R limit CPU means the maximum amount of CPU time in a second. R limit data means the maximum size in bytes of the data segment. R limit no file, the maximum number of files, that is number of files per process. These are the sum of the resources. Then next we will see the structure of the resource limit. See, R limit of the current soft link, that is the current limit, and the maximum how much it will require, that is the hard limit, maximum value for the R limit. Okay. So next is UNIX kernel support for the process. Okay, here this is the UNIX process data structures. It has the process table where each process are going to have the region table, that is per process region tables. Then each process have the file descriptor table and the current directory roots there. So process are going to be present in the, they are going to have access to the per process region where they are going to have the access to the kernel region table where the kernel is going to have the direct access to the text data and the stack segments there. From accessing here they are going to perform the operations there. Next is parent and child relationship after calling the fork there. So parent will be there and child, both are processes, so they are going to present in the process table, but they have the different file descriptor table. Okay, parent has its own file descriptor table and child has its own file descriptor table, but let's see, the information regarding this will be present in the main file tables there. Then here process, it has this access to the stack data and the text and here child is also have the stack data and the text. As we can see, the data segment of your process table of the parent and the child, it will be accessed by the parent and child. Okay, they are going to have the same text there, but parent and child have their own stack and the data segments here separate. They have the separate data segment and the stack segment. Here also the parent have the separate data and the stack segment, but they have the same text segment.